Hi, sir.
Hi, Amy. How are you doing?
I'm good, thank you. How are you?
Everything good? Fine. So,
Yeah.
today we'll finally begin with circles, right?
Right.
So, have you learned about circles earlier in your junior classes? I mean, in grade 10?
Yeah, just a simple area of a circle, and yeah, nothing too complicated.
Okay. So, in that case, we'll begin with basic concepts. We'll take up some definitions, quickly go through a few examples where we are going to just find simple equations of circles with radius, diameter, and things like that. And then we'll get into the real questions, which should be good for a GCSE level A student like you, right? So that is the
Yeah.
plan for today. Okay.
Okay.
Now, so in this part of circles, what I'm planning to do is that we'll go kind of smoothly transition between what you know and what you really want to know, right? So in between, we'll take some simple questions. In any curriculum, there are some bridging gaps. So we'll go through those
Mhm.
quickly and then focus our attention to the concepts. And I'll also introduce you to some new concepts which are not there in your curriculum for now. Might be they might introduce it later, but
Oh,
those concepts will help you a lot in solving difficult questions. You're getting my idea. And
right.
yeah, and I picked up those concepts from vectors. And I know vectors is a part of your curriculum, which you're going to do, later on. So we
Yeah.
have some concepts from vectors, which we have pulled in, and you should use them now itself. Use the formula at least. We'll look into derivations and theory behind later. Okay.
Yeah.
So let me share with you some part of the lecture which I've already prepared. We'll actually split this into two parts. In part one, we'll go through some basic examples so that you're good in a way to do all the questions, I should say 90% of the questions from your book, right? And then once you're not very clear about few 10% of those, then along with that, I'll take up some other concepts so that, we build on what we've already learned. So that has been our policy since we started, and I hope it works, right?
Yeah, it does. Yeah.
Yeah. So circles. So we'll just talk about circles and related terms to begin with. So that will take a minute for us, and then we'll go into some important formulas. Now, when I say important formulas, you know about them. One of them is a new formula for you, which I said you will develop in vectors, but we are going to use it in our examples. Then
Oh,
we'll
right.
see, yeah, and then we are going to see equation of circles in many different ways. If the origin is the center of the circle, then the equation is very simple. X square plus y square equals to r square. Very simple. Now, if I change my origin, let's understand the concept, then we'll begin. So let's say we have the origin here. In that case, the equation of the circle is very simple. It is x squared plus y squared equals to r squared, right? You're quite familiar with this. But as soon as I change my origin, let's say from this place to some other place, it's like transformation, right? So it goes to the coordinates h and k. If you apply your transformations to this particular formula, since you moved right as far as x is concerned, you get x minus h whole square plus y, you move up, right? So we'll just write my y minus k whole square equals to r square. So that becomes your equation of circle when you move your point from one place to the other, right? So that becomes
Mm.
another form of the equation. So, and the third form is expand this. So when you expand this, you get another form which is written kind of like this: x squared plus y squared plus 2gx plus 2fy plus some constant c equals to 0. So clearly, when you expand a term a minus b whole square, you are going to get 2ab minus 2ab terms, correct?
Right.
So
Yeah.
that minus 2ab reminds you of relation with these parts, which is the the center and these terms, right? So you will learn here
Mhm.
that you can easily find the relation between them from this equation to that. Half minus half of this value will give you h, minus half of that will give you k, correct? So overview. So you kind of get how all these equations are related, correct? We'll also take us some special cases when the circle will actually touch these intercepts, right? X and Y intercepts. If that happens, then you can visualize that the center will be same distance from these 2 points, correct? So,
Right, yeah.
so the center will be, let's say, A distance from here and A from there, correct? So you, in a way, get a radius and the coordinate, both related. So, and the coordinates will be A comma A in this case. Is that clear for the circle center? Right?
Yeah.
If it is touching both the axes. Now, if it is touching one of them, then also you can figure out what the center could be. Let's say we have a circle which is kind of touching like this. In that case, now, you will have something like this. Maybe A is positive or negative, depending on which quadrant you are in, correct? Sometimes the circle could be just sitting on the axis, right? So in that case, it is, again, you can figure out, so one value is 0, the other value is A or B, depending on how far away it is from the axis, correct? So those are simple cases which can be derived very easily from these, but these are very important cases when you look from examination point of view, right? So my idea to begin with is to give you an overall picture of what we are going to do in this particular video, right? We are going to look into circle in so many different ways, where it is placed, whether it is placed with the center at the origin, whether it is placed with center on the axis, whether it is placed on the line which is y equals to x or y equals to minus x, whether it is tangent to a particular line or something like I've shown here in the figure itself between two lines somewhere, right? So those are the type of questions which we are going to look into. So I hope that gives you a fairly good idea about what we are going to learn today, right?
Yeah. Could I just quickly ask a question?
Yes, yes.
When it says, the x minus h whole squared plus y minus k, how did you get the g and the f again?
Oh, I see. Okay. So basically, if you expand this, you get what? You get x squared minus 2 hx, right? Plus plus h squared. That is kind of thing you are going to get. Is that clear to you, right?
Yeah.
So basically, this term, center coordinate is h, correct? And here what we have? G, corresponding position. Do you see that G and H? Let me highlight. So you can write that the center is minus G minus F. Because we have a negative sign here. Do you see this negative sign? But here we have a positive sign.
Yeah.
So H should be equals to minus G.
Oh, yeah.
So simple, right? Do you understand?
Yeah,
and similarly, K will be equal to minus F, because I made them positive. Do you see that? When we write an equation, we like to write all positive terms, right? But, if I expand this, you get minus 2gx minus 2ky, correct? So we are writing another term, f and g, but that is how they are related.
Okay.
You get my idea. So, and this constant term, you will be wondering where that goes. These are all constants. These are all consumed by C. So you'll have a k square term and you have this minus r square term. All these three will be C.
Oh.
So easy to correlate. So it's not a big deal, right? So do you understand now all these equations? How are they related? Do you understand? Right?
Yeah,
all the three?
I do. Yeah.
Beautiful. If you have understood this, I don't have to take today's lecture because this is what I'm going to teach you today.
Oh, okay, fine. I don't understand.
Okay, that's very good actually to begin with. Perfect. Now, so that means we'll talk about equation of circle in standard form. So one of these is called kind of a standard form. Equation of circle with h and k, that is what we'll talk about. Equation of circle with center 0, that is what we are going to talk about. You see how many I've already highlighted, right? Then equations, and find the circle parameters from equation. You just figured it out how to find h and k, which is the center, and the radius we figured out is related to this. So those are the parameters. There are only two parameters for a circle. One is the center, the other one is the radius, right? And then equation of circle with intercepts, we were just talking about this, right? Equation of circle with intercepts. And then equation of circle with diameters, that is interesting. I didn't talk about, so we discussed that at length. Good. And we got something to work with, right? Examples, examples with tangents and normals. That is a very interesting question. We should actually talk about it at length. An equation of circle from 3 points. Now, why 3 points for a circle?
I remember you saying this last lesson. 3 points, like you can define a circle with 3 points.
Correct.
So as long as they're in the plane or something.
Correct.
Yeah.
So if you want to really identify a circle, you need 3 points on it. So if you get 3 points, only one circle can pass through these points. And let's say we have these points right there, something like this. Then the right bisectors will go through the center of these points, and then you will define your circle. Correct? So that is what we are going to learn. Perfect. So quickly, let's go through the definitions. So can you read these definitions for me? I know you are fairly conversant with them.
Yes.
Yeah.
The circle is defined as the locus of all points in a plane, which are at a fixed distance from a given point. The fixed point is called the center of the circle, and the constant distance is called the radius of the circle. The diameter is the longest chord that passes through the center, and its length is twice the radius.
Correct.
The tangent line is perpendicular to the radius at the point of tangency. The right bisector of a chord will always include the center.
That is true.
So right bisectors of chords intersect at the center of the circle.
Right.
Yeah.
So that is your chord, right? This is your chord. So if I do a right bisector of this particular chord, it will definitely go through the center. That is kind of very important property. Correct. And next.
And the equation of the circle represents all the points on the circumference.
Perfect. So when we say right equation of the circle, we're looking at that loci, fixed distance away from the center, and that periphery is the circumference, which you fairly well know about. Correct? Now here are some important formulas which you've learned in past, and let's do a quick review, because circle we are not talking about in isolation. We'll look into points, the lines, the tangents, normal, distance, so many other things, right? So the very first and the most important formula which you're going to come across is the distance formula, which is derived from Pythagorean theorem, square root of x2 minus x1 whole square plus y2 minus y1 whole square, where x1, y1, x2, y2 are the 2 points. Perfect. Then we need to find the midpoint, then just have average of these two values, x1, x2, y1, y2. That gives you the midpoint, right? Then equation of the line. Equation of the line could be written in many different ways. You know, slope-intercept form, point and slope form, standard form. 3 of them are right before you. My reason of picking these 3 is very simple. Now, from this particular form, you know slope m, right? Basically, it is y2 minus y1 over x2 minus x1. Now, if I give you a line in this form, can you tell me what is the slope for this line? To get the slope, you have to rearrange, right? So when you rearrange, you get a to the next, you get minus a over b as the slope. But this equation normally is used to find the normal. So normal is reciprocal of slope 1 over m, and that is b over a. So b is the coefficient of y, and a is the coefficient of x, right? When we do vectors later, we'll just write this as ab, right? So b over a, that will be a normal, or we can also say ab, right? So that is the normal. Now, normal is very important, since normal gives you the shortest distance. So if I have a line here, and then if I have a slope kind of like this, which is at right angles, right? Then I can actually find shortest distance from a point to a line. Do you see that? Then what are we looking into? We are looking into normal, right? We are looking into the normal. This is M and that is the normal. Do you see that? Shortest distance is along the normal. And that is why this important equation is mentioned here. Now, its importance is highlighted when you look into this formula, which is distance of a point P from the line AX plus BY plus C equals to 0. Now, what do you really do to find the distance from a point to a line, which I've mentioned here, is only substitute X and Y values with the point XY values, correct? So if you know that the point XY values are X1 and Y1, just substitute these values right there and you get the distance. You see how easy it is to find the distance from a point to a line. And that helps you to answer many questions like in circles, if I know the point, which is the center, and the line, which is the tangent, I get the radius straight away using this particular formula. Now, the derivation of this formula, we are not taking up in today's lecture. It has been derived in so many examples of mine you can look into. Plus, well, actually, when we look into vectors, we are going to see it in a different highlight. It will make a lot more sense. But let's try to use this formula right away, okay? It's a very standard formula. Now, to begin with, we'll start with very, very simple questions. So here, the very first question is, well, it is not a question. We will derive the formula, right? So we are trying to figure out what is the equation of the circle. Now, in this particular case, we are given the center HK and the point P on the circumference, which is XY. Now, basically, we just want to find the radius related with these 2 points. Radius is fixed. That means we have fixed the circle also, right? So we can use the distance formula very easily between these 2 points. We know these 2 points, correct? And the distance formula is Pythagorean theorem. So that distance CP is equals to x minus h whole square plus y minus k whole square root, and that's the radius. And if you square this, you get the equation of the circle. Do you see how easy it is to derive the equation of the circle? As simple as the circle itself, right? So the most beautiful structure you have and the most simplest of all the equation you have to support it, which is x minus h whole square plus y minus k whole square equals to r square, right? You just get it. Now, if I replace h and k with 0, 0, that is to say, if I make it center at the origin itself of the coordinate plane, in that case, it is even simpler. X square plus y square equals to r square. We're done about it. Do you see that? But you know what? We don't want to keep things simple with you. We're complicated to the extent you won't believe it. So what we are trying to do is trying to complicate, but you are my students, so let me share with you the secrets behind, okay? So what am I doing here is complicating your simple equation. We have x minus h whole square plus y minus k whole square equals to r square, correct? Let us expand it. Let's expand it, right? So when you expand, you get x squared minus 2xh plus h squared, 3 terms out of these 2, 3 more from those, and then we have r squared as the other term. Now what we're trying to do is rearrange. We're bringing r squared to the left side, making the right side as 0. And we have few constants here, as you can see, h, k, and r brought on this side. So these 3 terms are there clubbed together as a constant. They are not going to vary with your h and, right? Once you are given the center of the circle, they are not going to vary, but these are all numbers. We club these numbers together and we say, well, that is the term C for us. Is that clear to you? Very good.
Yeah.
Now, the next term to look at is this, 2hx. But we would like to see all our equations not with the negative sign here. So what we do is, instead of h and k, we define 2 more variables, and these variables are g and f. Very standard. Every book follows this particular nomenclature. So these are the, I should say the transformation of a simple equation into a complicated one, which we will call standard equation by standards of whatever we are learning. So we'll call this as our standard equation. Do you see that?
Yeah.
So that really makes things interesting because it was such a simple equation. There was nothing to work with these 2 equations, right? You can't really create good problems with these 2 simple equations. So we standardized the equation in our big way, right? So, and this is our standard equation. Do you see the standard equation now?
Yeah.
It is still smaller because for C, or this is the term. This should be R here. Okay, sorry for that. This is R square. Okay, perfect. That term is the constant now, correct? So x square plus y square plus 2gx plus 2fy plus c equals to 0 is called a standard equation. Now you can actually see how it is related to our simple equation which we began with. So the relation is very simple. The center we're talking about now, if you look into this equation, compare with the previous one, the center now is not that hk, but minus g minus f. Do you see that?
Mhm.
And the radius is now this huge term. I mean, yeah, I mean, radius is related with c. Oh, sorry, this was okay then. Wait a minute. Correct. So constant C we rearranged. Okay.
Oh, okay.
Yeah. Let me just because so we have h square plus k square minus r square equals to the constant C. So we just brought the C there. So we have h square plus k square minus C equals to r square. Correct. And then we say square root. I mean h square plus k square minus C is equals to R. Is that clear to you? So that is how we get this particular equation.
All right. Yeah. Mhm.
So yeah, so once you have this particular equation which is normally given to you, x square plus y square, for example, I'll give you a circle equation is x square plus y square plus 6x plus 8y plus let us say some 3 equals to 0. I'll give you that equation. This is the equation of the circle. Find the center and the radius. How will you do it? Well, you will say the radius and the center. Radius will be minus, I mean, the center will be minus 3, negative and half of it, and negative and half of 8. That is your center. Is that clear to you? When I give you this as your standard equation, because that is how my center is related. Negative and half of this value is the x value of the center. Negative and half of 8 is negative 4. And to find the radius, I will use these two values, which is 3 square plus 4 square minus c, and the square root this to find radius r. Is that clear to you? So in this case, I just randomly picked up the values, 3 square root of 2. So radius will be square root of 2 from this particular equation, right?
Oh, okay.
Slightly complicated to start with, but that is all we are going to learn in today's lecture, believe me. Okay, this is it. So I think second time we have learned the same thing, but let's move forward. We have to complicate it further for you, okay, so that it becomes more interesting. But let's begin with simpler examples again as we did earlier. So again, we'll look into example 1, equation of circle. Find the equation of circle with radius 7 and origin at center. What should be the equation? Origin at center, radius 7. Well, x square plus y square is 7 squared. Done. Correct?
Mhm. Yeah.
Right? And if you have to derive it from the definition, that is another point. Sometimes you may have to derive from the definition itself. So the center is 0 and the point is here. Using Pythagorean theorem for the distance formula, x2 minus x1 plus y2 minus y1, both are squared, is equal to the radius square, and you get this because the center is at origin, right? So you get your equation. So you could always derive this even if you've forgotten the formula to begin with. Clear?
Yes.
Now example number 2, slightly more difficult. It says a circle is defined by the equation x square plus y square equals to 64. So what should be the center of this equation? Can you tell me, circle?
The origin.
Perfect. What should be the diameter?
So since the radius is 8, we just do the diameter, which is double. So 8 times 2, 16.
How do you find the y-intercept of a circle given the equation?
We just sub x as 0, and there will be y squared equals 64. So square root of 64 is plus or minus 8.
Yeah, and for y-intercept, you can do all that. Perfectly fine. So let's move on to the next example. Easy for you, right? No difficulties?
Not so far.
Example 3, equation of circle. The circle with center 0, 0 passes through a point this time. So we have not given you the radius, we have given you point and the center. You can find the distance between them using distance formula, right? 6 square and 8 square, square root will give you 10, perfect. So once you find the radius using this Pythagorean theorem, you know the radius, and since we know that the origin is the center, general equation is x square plus y square equals to r square. So it is simple, x square plus y square equals to 10 square, 100 is the value. You get the equation of the circle. Now part B is find x and y intercepts. So as we did last time, just substitute x equals to 0 to get the y-intercept, and then y equals to 0 to get the x-intercept. Both will be plus and minus 10 in this particular case. Done. Part C is kind of interesting. Can you answer this question? Find the coordinates of Q if QP is the diameter. So we will extend this and we have a point Q. How will you find Q from this situation? Tell me, please.
So since I remember last time we were talking about the midpoint formula.
Yeah, yeah.
So we would just make, so since between P and Q, as it's the diameter, the center is midpoint. So we would use that at the beginning of the equation. So 0, 0 equals, so make Q equal x2 and y2, or vice versa, it doesn't really matter. And then you just do x plus 6 over 2 and y plus 8 over 2.
Correct.
That's the two coordinates. Make the two formulas equal to 0, because in this case the center is 0, 0, and we get our 2 points.
Simple as that.
Yeah.
So you get the point very simply as we just described. Perfect. Let's move on and go to the general equation of the circle, which is kind of complicated in a simple story, right? So the equation here is find the equation of circle with radius 8, and we have changed the center to -2, 3, right? So -2, 3 means we'll translate our point from center to the center point C, which is at -2 and 3. So we get our equation, which is x minus h whole square plus y minus k whole square equals to r square. We just derived this equation in example 1, correct? Now, we'll put this point C -2, which becomes here +2, and 3, which is -3 whole square. Radius is given to us as 8, so 8 square. Expand and simplify. Bring 64 to the left side, add all the terms to get a constant, which is -51 in this case. And this form of the equation is the equation of the circle in standard form. Got it?
Can we not leave it in like x plus 2 whole squared?
Not interesting. It's not interesting. That was there in the question, right? So we could leave it here. Yes. But the question says equation of a general circle, and if they say standard form.
Oh, then you have to use that form.
Only then you do all this. Otherwise, your bright student, just leave it there. That is good enough.
Oh.
You're right.
It was with the exam timing, that's all.
Perfect.
If specify, then yeah, definitely do that.
Agreed, agreed. So with the limited examples I've taken, I thought I'll go through some complications. However, now let's get back to this equation. Amy, can you tell me if you are given this equation, right? What is the center point? Can you tell me from this equation?
Okay, so we would start by, can you inverse the sign? So we know it will be minus. And then 4 divided by 2 is 2, so -2. And then inverse the sign, so it has to be positive. So 6 divided by 2 is 3. So -3.
What is the value of r? What is the value of r? Tell me. R.
Okay, so
square of this, which is 4. Square of this, 9. And negative of this, which is +51. Correct?
Right. So 13 at 51 is 64. Is it? Oh, so square root of that is 8. Oh.
Understood?
Yes.
Done. This was the next example anyway. We'll skip that one. So let's go to another example, okay?
Oh, can I just quickly take a picture of that?
Sure, why not?
Just a sec. Okay. Thank you.
So this is a good exercise. I mean, when you find an equation, just check, do you get the same values as expected, right? It's good fun. So I think you really like circles, like starting from one place and getting back to the same place. That is what we are doing all throughout, right? Nothing new here.
Right.
Completing the squares method. You remember completing the squares method?
Yeah.
Find maximum, minimum, and all that, correct?
Yeah.
After all, in circle also we have x squared terms, so that could be handy for us. Let's see how. So example number 5 for us is, we'll find center and the radius from the equation given to us. Not the way you did last time, right? That was very simple, correct?
Yeah.
Now, look here. Find the center and the radius of the circle x squared plus y squared minus 2x plus 8y plus 8 equals to 0. You could find the, as you did last time. So let's do it last time. How did you do? Let's write down the center C. C should be what? Half of this with the negative sign. Negative sign half means -4. Is that clear to you?
Yeah.
And the radius is what? Square of this, which is 1, plus square of this, which is 16, minus this term, 8. Is that clear? Which is what? Square root of 9, which is 3. Is that clear to you? Well, that is too simple, and we don't like this method, right? So we'll teach you another new method.
I like simple. But
Too simple now. We'll do completing the squares method to find the center and the radius. Perfect. So what to do now? Well, we have x squared plus y squared minus 2x plus 8y plus 8 equals to 0. Rearrange the terms. Bring this x together with x squared, y term with y. Leave the constants aside. Now what? Half of -2 or half of 2 is 1, right? So add and subtract 1 square. So we did this, right? You see that? Half of 8 is 4. Add and subtract 4 square. Perfect. Do you see completing the squares?
Yeah.
Half it and square it, add and subtract both the terms. We did so. But that helped us to find a perfect square, right? These three terms can be combined. And we can now write this as x minus 1 whole square plus y plus 4 whole square. And that becomes -9 equals to 0. Things are making sense now, right? So we have our equation of the circle, x minus 1 whole square plus y plus 4 whole square equals to 9. Well, that tells us that the center should be 1 and -4, and the radius should be square root of 9. That is 3. Do you see that?
Yeah.
So you could do with completing the squares also the same thing. Perfect. And there is your circle with radius 3 and center 1 minus 4. You like it?
Yeah.
You adopted a simpler method using this formula. Well, that's your choice. But if I write completing the squares, you have to do like this as shown. Okay? We are teaching you new methods. Perfect. Sometimes some methods are better. Okay. Next example. Example number 6. We're now talking about equation of circle from Y-intercept. Well, this is a very interesting question, Amy. So can you please read the question for me?
Yes. Example 6, equation of the circle from Y-intercepts. A circle with radius of 5 units passes through the points A, 0, 0 and B, 0, 6. Find the possible equation of the circle or circles.
Correct. So whenever in the test question you have that's S, that means there is a possibility of getting more than one equation. Now it makes sense. What are we given? We are saying that this circle with radius of 5 units passes through these 2 points A and B. Well, if it is 2 points, you can draw many circles, right? You can actually draw many circles. But we are also given radius of 5 units. That means we are limited to 2 circles because we have fixed the radius. If we do not fix the radius, you can draw infinite circles with 2 points. Only 3 points will define a circle. In this case, we restricted radius, so we are left with 2 circles. Now look here. So we are given point A and B. Let's try to understand the scenario. Fortunately, these points are Y-intercepts kind of. 0, 0 and 0, 6 means a vertical line right there, right? Is the chord, which is AB, a vertical line.
Yeah.
The
Yeah.
center lies on the right bisector of this chord. So I'll find the center of this chord, which is at 3, right? Between 0 and 6, the center has to be at 3. The x value will be 0. Perfect. But we want to go this side, right bisector. So y equals to 3 is my horizontal line on which the center will be there. But what we know about the center is that it is 5 units from the periphery. So you see that 5 units drawn here.
Yeah.
So this 5 units. So we know this is my chord AB. We have a right bisector which is y equals to 3. I can select a point, but this point should be 5 units from A or B, correct? That's the radius. So 5 units from there. But I have a right triangle because that is a vertical line. Right bisector makes it 90 degrees. And hypotenuse is 5, base is 3 units away. Correct? Sorry. The up one side is 3 units away, the opposite side, correct? So you can use Pythagorean theorem to find the third side. Is that clear to you?
Yeah.
Correct. So we have understood the concept. Now let's go through the solution of this particular question. So in question number 6, we'll solve using the fact that the center is on the right bisector of the chord. So we have to find the center. Basically, we'll first write the equation of right bisector. So the right bisector of the chord AB, which goes through the point 0, 0 and 0, 6, is to be found. So first step, find the middle value, the center. Average of these two zeros will be 0. Average of 0 and 6 will be 3. So straight away I've written the value 0 and 3. Now, equation of the right bisector, well, that is a vertical line, correct? So A and B is a vertical line. So A and B is a vertical line. Right bisector is horizontal line. So horizontal line equation should be y equals to 3. Since it goes through the midpoint, m equals to 0, 3. Does it make sense to you?
Yeah.
Perfect. So we have that. Now we don't know how far it is, but we know how much high from the x-axis. So that point we know from here, at least it is 3 units, but we don't know how far it is from here. So let's take this as A. So my point is A3. But I know that the radius is 5. So applying the Pythagorean theorem, I can find A value. So A squared plus 3 squared is 5 squared. Simple as that. And now you can solve this equation, find possible values of A. When you do square root of 16, you expect 2 answers, plus and minus 4. So that could be on either side. Just get the idea, right?
That makes sense, yeah.
Perfect. Now you know the center and you know the radius. So you can write the equation using your standard formula. X minus h whole square plus y minus k whole square equals to r square. Just substitute the new found coordinates A and 3. A could be plus or minus 4. So we get 2 different equations, right? So that gives you the answer. 5 squared is 25, and here is the result. Is that clear? Very interesting question.
Yeah.
You are given a chord, but this time the chord was a vertical line, so easy to make that horizontal line connection. Y equals to constant 3 in this case, and so we got it. Well, difficult question could be if I don't give you A and B as a vertical line. If I give you at an angle, you may have to do some more calculations. Okay, let's move on to question number 7. Example 7 here is equation of circle tangent to a line and the axis. So we kind of complicated all of a sudden. So what we have done now, we're talking about find the equation of a circle in the third quadrant. This is your third quadrant, correct?
Yeah.
In the third quadrant that touches both the axes, that means it is tangent to this as well as this, both the axis and a line also, 3x minus 4y plus 10, and the line. So we have defined a circle which is tangent to both the axes and also to a line. So that is a very interesting question for us to do. I'm going to apply a very simple method to solve this and see the strategy. Since I know that this circle is touching both these points, correct? So it is same distance because the radius is same, correct?
Yeah.
That way or this way, the radius is same. So I'm saying, well, that means the radius is same. Let it be A. So A is my radius. Since it is A units away from x-axis, A units away from the y-axis, but we are in quadrant 3. Since we are in quadrant 3, the center should be at minus A minus A. Does it make sense?
Yeah.
First thing. Now, we learn what is the distance formula from a line to the center. We know the center is minus A, and we know the equation of the line, which is tangent, is 3x minus 4y plus 8 equals to 0. So if I know what is the distance from here to here, I know the radius.
Oh, yeah.
You get the idea? So that is my radius, which is A in this case. So I'm equating A, the radius, to my distance formula. Equation of the line replaced with A, minus A minus A. You got the idea?
Yeah.
Dividing by 3 square plus 4 square square root. So this is your distance from a point formula, which we shared in the beginning. Very important formula. Straight away we applied this particular formula and wrote distance is always an absolute value. Therefore, we have written this absolute sign. Now, very simple. Minus 3a plus 4a plus 8 gives you a plus 8 in the numerator. Denominator is 3 square plus 4 square square root, which you know is 5. And now you cross multiply, find the value of a. A comes out to be 2. Since you know a is 2, we actually got our radius. A is the radius. Also the center, minus 2 minus 2. Correct?
Yeah.
Everything is there. So that goes with our equation fairly well. X minus 2 whole square plus y minus 2 whole square equals to 4. You get how simple it becomes when I use this distance formula to find it?
Yeah.
Otherwise,
I didn't realize.
otherwise, what will you do? Tell me. If you don't use the distance formula, how will you do this question? Tell me.
Okay, wait. Well, we can see, so it touches the axes. So the 2 points on the axes, you could make a chord and then do the right bisector, find the center of the circle.
Oh, that's a good idea. I like that. I like that part. I never thought about it. I mean, that is so brilliant. So, you know, these 2 points you're saying you could use, and then you have a chord which goes through the center. Perfect. And there is no harm in selecting C as minus A, you know, because it makes sense, same distance away. But now remember, we have this equation which is, let me write here, 3x minus 4y plus 8, correct? So we are looking that this should be perpendicular to that. The shortest distance radius should be perpendicular. So the normal here will be what? So the normal here will be y value over minus 4 over 3. Do you see that?
3, yeah.
So you know the normal. So once you know the normal, and you know this point here is minus A, correct? You can find that equation also. And the 2 equations which you are working with, find the point of intersection. You know what A is. You got it. But anyway, it is going to be slightly more complicated than what we did. That's the whole idea, right?
Yeah, but if you forgot that formula,
then you have to do like that.
There are other ways, yeah.
Okay, so we'll leave this for the last question because I really want to have a tough question at the end. How to make it tough is how to solve it in a very difficult way, okay? So we'll keep it for the last, okay? Now, but anyway, if you remember this formula, this is like a very beautiful solution. And this formula can help you to solve the most difficult question in your exercise book. Let me tell you that, okay? Yes, so it's a key to remember. Next, example 8. In this case, can you please read the question for me?
Yes. Example 8. Equation of the circle from diameter coordinates.
So we given.
Find the.
Yeah.
Sorry. Yeah.
Yeah. Continue.
Oh, thanks. Find the equation of the circle with diameter points as A being x1, y1 and B being x2, y2.
Correct. Now that's again a very beautiful question, and what we are going to derive is a very interesting equation, Amy. Just as the last formula, you should remember the formula which you are going to derive is so simple. Another equation formula which is so simple. The formula is x minus x1 times x minus x2, since we are dealing with 2 points A and B, right? x1, x2,
Right.
right? Plus y minus y1 times y minus y2 equals to 0. Simple as that. Simplest formula for a circle given 2 points which form the diameter, right? And see how easy it is to derive this formula. So we have now 2 points. Let us consider another point C on the circumference. Since we know the diameter, and if I connect C with A and B, what will I get? I'll get a right triangle, correct? It is in the semicircle.
Oh, yeah.
So when you get the right triangle, two sides are perpendicular, negative reciprocal is their slope. So we derive a slope formula. So we know x1, x2, y1, y2. So find slope of A and C, find slope of B and C, and relate them with negative reciprocal. So clearly, y minus y1 over x minus x1 is slope of A and B. Slope of B and C will be, we flipped it, right? Negative reciprocal. Y minus y2 goes in the denominator, x minus x2 comes to the numerator with a negative sign. Cross multiply to get this. Bring the terms together to get your formula, which is right there. Easy to remember, easy to derive. Given 2 points which are the diameter of a circle, x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals to 0 is your next formula to remember.
Oh, that's really handy. Yeah.
And it's not given in books, okay? It's not given in your book, at least the pages which you shared with me. So that could be a brilliant formula for you. So add it to your formula list, okay?
Okay. Yeah.
Example 9. Equation of circle from diameter coordinates. This is just a practice on the formula we just derived, kind of application.
Oh, okay.
So find the equation of circle with the diameter points A as 1, 2, and B as 9, 6. So we already know the formula. Substitute x1, y1 values, expand, and all this. You get your circle equation in standard form, which is x squared plus y squared minus 10x minus 8y plus 21 equals to 0. Is that clear to you?
Yeah.
Correct. Now, if you do not know this formula, then what will you do? In that case, your alternate method will be first find the midpoint, correct?
Midpoint.
That will be the center, and then you find the radius. Correct? Distance from center to one of the corners. Or you can just find the length of the diameter and half it. So you can do diameter by 2, radius. So once you have these two, you will get the equation of the circle easy. Do you get the idea?
Yeah.
But here, if you know the formula, which is so simple, directly substitute the values and get your answer. So genuine question from test point of view with 2 different solutions, one being so simple as that, right? Do you see that?
Yeah.
Yes. Now, 2 points diameter we have defined. Here is another question which says, example 10, equation of circle from intercepts. So we will consider intercepts, that means x-intercepts, y-intercepts, right? So here we are also taking origin into consideration. The question is, find the equation of the circle which passes through the points A, B, and C, where A is the origin, 0, 0, B is 3, 0, the x-intercept, C is 0, 4, the y-intercept. So we are given these 2 intercepts and the origin. You need to find the equation. So how will you find this equation? Tell me.
Wait, so A is 0, 0, B is 3, 0.
Here is B. So we got 3 points. A circle is being uniquely identified with these 3 points. And now I'll tell you one key thing. Yes. Do you have an idea? How will you answer this question?
So if you draw the chord between A and B,
yeah,
is fine, and then you find the midpoint of that.
Correct.
And then you can find the radius from that by doing
Correct.
Pythagoras
Easy.
theorem.
You could go with this. Right bisector of this side, this is also a chord, correct? Right bisector of this side will give you the center. These are your two chords, right?
Like the other
Nothing is
question.
horizontal and vertical line. I mean, it's so easy. Half of this and half of this. Do you get the idea?
Yeah.
Correct? So you easily get your answer. So you could do like that. Does it make sense?
Yeah.
That could be one method. Another method is you also observe is, if we have to look into different ways of solving, since in examination you don't know what will click, right? And sometimes the questions are so defined that one method is preferred over the other. You also notice that this is right angle, correct?
Yeah.
Both the axes will always intersect at right angle. Clearly, that means that this is the diameter.
Oh, you can see that.
We know the diameter. Come on, we know these points. That means we know everything. We know the radius and we know the center. Does it make sense to you?
That's good. Oh, so that's quite cool. So even if you get stuck on one of them, there's so many other alternate strategies you can use.
Correct. And if you really want to show that you know a lot, use the diameter equation. You know the 2 points of the diameter. Use that particular equation and find your answer. Does it make sense?
Yeah. Oh,
so,
yeah. So you could just use the points they're given, but you can only do that because there was a right angle there. Right.
Correct.
Okay.
There was a right angle there. So what I'm trying to say here is that they may give you a figure. They may not say it is on origin, it is on that point, this point, and all that thing. But if you notice that the point is making a right angle, then the other two are on the diagonal.
Oh.
Since the other two are on the diagonal, straight away use the diagonal equation, get your answer.
Perfect. Okay. Yeah.
You get the idea. So it is like combining all the things which we have learned so far. Difficult questions can be easily answered. You just think about it. If I add just a value -2 to all these values, right, then relatively the position remains the same, but it is not x-intercept, y-intercept, and the origin. These not so simple points to work with, right? You get some -2, some values like that, correct? But you see, you have recognized that these are perpendicular lines, so 90 degrees, and the 2 points given to you are actually forming the diagonal of a circle. And therefore, I could use this particular equation and solve my question straight away.
Yeah.
Got the idea? So that is how we are going to solve this particular equation, but there are so many different ways. So identify that we have a right angle at that corner origin, and therefore the other 2 points are part of a diagonal on a circle. So we'll use our diagonal equation, write down the equation. We're done. Is that clear to you? But you could definitely adopt many other ways of doing it, right? Right. So we'll move on, take up example number 11. A lot of examples for us. Example 11 here is the most difficult question actually. Equation of circle with parallel tangents. So you could have parallel tangents on either side. So I made a circle here which says find the equation of the circle whose center lies on a line y equals to -2x. So this is your line and the center lies on this particular line y equals to -2x. With tangent lines, we are given 2 lines. These 2 are tangents. You have to find equation of this particular circle. Now that is very typical, right? How do you figure this out? Remember, since this line is the one on which the circle lies, necessarily the points of intersection of the line and the tangent lines will not be part of circle. So sometimes students do that mistake of finding the point of intersection and using that as your diagonal points. That is not going to be the case. As you can clearly see, point A is further away from the circle and B is also further away, correct? They are not at the point of tangency, right? Do you see that? So the lines which are tangent to the circle, they are tangent at different points, let's say P and Q, okay? and the circle lies on the line which is intersecting on totally different points. Is that clear to you?
Are you saying students use the point where the tangent meets the circle as the diameter, those 2 points?
The students will do, I've seen what students will do, use this line y equals to minus 2x on which the center lies, and then this line and this line to find the point of intersection, which is A and B. And they think A and B is on the circle, and they choose that as a diameter.
Oh, is that not? It's not on the circle.
It is not on the circle.
Oh, it's on the line. It's on the tangent.
It's on the line. It's on the line. It may not be on the. Yeah, it's on the line and on the tangent line, but not on the circle.
But it's not on the circle.
These two lines are tangent at a different point. You getting my point? They are tangent somewhere there.
Oh, they're there. Oh.
Somewhere there.
Oh. Right. Okay.
So first thing is to understand what mistakes we need to avoid and then solve.
Yeah.
Clear to you? Okay.
Yeah.
Very important. Okay. To begin with, I'm writing alternate strategies. I don't know why I wrote this. Maybe I was thinking some other strategy, but didn't do that well. Oh, I don't know. Alternate strategy, right? So both tangents are parallel, intersected by a line. That is the situation given to us. Center is midway between these 2 points. When you find these 2 points, midway is the center. That is clear. Is that okay?
Yeah.
So we'll definitely find the point of intersection between the lines, and we are only going to use those points to find the midpoint to get the center. Is that clear to you?
Yeah.
So point C is midway of those 2 points A and B. So using those 2 points, we got the midpoint. That is simple as that. And then what I did, I know the midpoint and I know the tangent. What should I do? I should use my formula, distance formula, to find the radius.
Could you just explain that, if that's all right, just one more time?
So
that formula is kind of new to me.
Yes. So did you get the center? How did we find the center? Since we have 2 parallel lines, let's say we have 2 parallel lines, correct? And we have a transverse line, and the center is on that line, and these were also tangent. So these are parallel lines, correct? So if we have a circle anywhere in between, this center of these 2 points is the center. Midpoint of these 2 points is the center.
Okay.
Right? These 2 points are not on the circle, but they are same distance away from the center. Correct?
Correct. Okay.
This distance and this distance is same.
Yeah. Oh, okay.
We got the center point. So center point is the average value of the point of intersection. So we first found point A and B, which are these 2 points outside the circle.
And we found that by making the line equal to
Y equals to minus 2.
the tangent.
Tangent equals to the other intersecting lines. Yes.
Okay. Yeah.
So we have 2 tangents, so we get 2 points, A and B.
Okay.
So simultaneously solve these 2 equations. You get 2 points which are on the extreme. Midpoint gives you the midpoint of the circle, center of the circle. Now, we also understand that we have a tangent there, and from midpoint to tangent is the shortest distance. So when I'm looking at these 2 points, we're looking at the shortest distance. And this shortest distance is the distance from tangent line to the center. So we used our distance formula. Radius is ax1 plus by1 plus c, absolute value, divided by a square plus b square square root.
Could you just explain how to use the formula again? So
Okay. Yes.
A, B, and C. I don't get that.
Okay. So I'll write the A, B, and C is the equation of the line. So in this particular case, I've used the equation of the line, which is 4x minus 3y plus 10.
Why didn't you use the other equation?
You could use the other equation also. No problems.
Oh, okay.
Right? So that is my equation. And the point P, which let me call this as center C as I've written there, is 1 minus 2. So in the formula, you have to replace x with 1, y with minus 2. So when you replace x with 1, you get 4 times 1 minus 3 times minus 2 plus 10. Absolute.
Oh, I
That's
see.
the numerator.
Yeah.
And 4 square plus 3 square comes with the denominator, square root.
Mm-hmm.
So substitute those values and calculate. So when you calculate, you get the value of 4.
So you're saying with so to find the radius using that formula, does it have to be in like line? Like, can you use that formula on a circle equation, like the x squared plus y squared, that whole thing?
No, you can only use with the tangent and center.
Oh,
Because
okay.
the distance between tangent and center is radius.
Oh yeah. Oh yeah.
So
Because
we
the
want to
tangent's
find the
like this, the
radius.
center's here.
Correct. So only we will use, when we are talking about circle, you can use it any place, right? But in our case, we have to define a circle, which is defined by center and the radius. And fortunately, radius to a tangent is the minimum distance. It is at right angles, correct? So this formula is very important. And that is why this formula can be used. Perfect. Now,
That makes sense now.
that is why I'm calling this alternate strategy. This is not the strategy in any book. Correct?
Oh.
Alternate strategy. So we will do it with alternate strategy using our formula. Is that clear to you?
Yeah.
Correct. The other strategies, look into your book.
I'm okay. I'll use yours. Looks like the most efficient.
This is killer. I'm telling you. I mean, I was struggling with these types of questions, to be very frank with you. There are so many of these types of questions. They made my life like terrible. I couldn't really solve them most of the time. And you know, because you have to do slope, negative reciprocal, equation of a line, point of intersection. There are so many steps involved. Now, when you involve so many steps, you do a mistake. And then you don't get the right answer. What's the whole point? Now, when I learned vectors, I found that this is it. Point, distance formula.
This is the point. Oh
Then
my
you're done,
God.
right? And when in your curriculum you have to learn vectors, why not use that particular formula which you're going to learn soon?
Yeah.
Correct? Well, in coordinate geometry also we have a proof for this. I can actually share with you proof for this particular formula in coordinate geometry, but it's too lengthy. I mean, that's why I don't do it.
Yeah.
Too lengthy. In vectors, it is one statement, right? We just say it is a product, dot product, which is 0. It's like slope equation working. It is one line.
All right.
One line. So why to go for coordinate geometry proof? We'll ignore it, okay? We'll take the formula for now. And in a couple of weeks when we do vectors, you will kind of know this and you'll use it so many times that you'll never forget about it, okay?
All right.
So by the time you pick up GCSE, you will be like master on this.
Hopefully.
Anyway, so I hope you're liking introduction of this formula early on and how simple it makes all the calculations, correct?
That's so good, true, because just like you just mentioned right now, of all the things I would have had to done if this formula wasn't given, that's too long. Like, I can't do that. Yeah, and especially if you make a mistake, it's so hard to go back because there's already so much working and like it's just not. Nah.
Yeah.
So yeah, thank you for this.
Examination setting, and you got one radical root. I mean, you're doing square root, right? You got one radical root and a fraction. You cannot work with that. It is so difficult.
Yeah.
Let's be practical. So let's
be practical.
Already, you know, when we started with such a simple equation, we have complicated the equation to work with. And now again, add more complication. No, come on. We don't want to make it miserable, right? Have fun.
I didn't realize how complicated you would make it.
Example 12, equation of tangent and area, right? This is very simple, but it is an example which gives you insight to some difficult questions in test papers. But I've taken a very simple example only for you to understand the concept. Is that clear?
Okay.
Now, can you please read the question?
Yes. Tangent at point P being -3, 4 to the circle O with center at the origin cuts the coordinate axes at A and B. Find the area of the triangle OAB.
Which is shaded in orange for you, right? So you just need to find this particular area triangle. So basically, we have to find the equation of the tangent line and its intercepts. Once you find the intercepts, half base into height will give you the area of the triangle, right? Now, the equation of the tangent. How are you going to find the equation of the tangent? We are given the origin, right? So we know the point. We can definitely find the radius, and we have the equation also, correct? Now, look here at the strategy which we have adopted. OP, this O to P, is the radius, and definitely the length has to be 3 square plus 4 square square root, which gives you the value 5, correct? So the equation with the center 0 is x square plus y square equals to 5 square, which is 25. So we easily get the equation of the circle once we have a point as simple as 3 and 4 on it, right? Now, we have to get the equation of the tangent line. Tangent line is normal to that equation. So negative reciprocal of the slope gives us the slope of the tangent. We already know a point on the tangent. We'll use slope. You can use any form. But I like this point and slope form equation to use, since that radical, the fraction 3 or 4 could be cross multiplied, and easily you can get the equation of the line. So here we have the equation of the line, which is 3x minus 4y plus 25. Is that clear to you? Starting from slope of the tangent being 3 over 4 and the point being minus 3, 4. We get this point. Once you have this point, find x and y intercepts by substituting in terms x equals to 0 and y equals to 0. Get your answer, right? So I substituted both 0 here. Let me make a correction. This should be y, correct? So, and then you get the y value and the x value. When you get these two values, half intercepts product gives you the answer. Half base into height, correct? So you know this intercept and that intercept, half base into height gives you the answer. Area should be 625 over 24 units square in fractions. Is that clear to you?
Yes.
If you want to find it in 3 significant figures, use calculator, figure it out. But anyway, this is a very interesting question. Your circle may not be at the center. It makes it more interesting, but the idea is clear, right? So radius is tangential. Radius and tangent will be at right angles. That gives you the slope. Once you have the slope and a point, you can find the equation. And once you have the equation, you can find the intercepts. Clear? Example 13. Okay. So we are now looking into equation of a perpendicular line, which is basically tangent. So I think it's kind of repetition of the last question. Point P, this time we are not giving you the point. We are saying A12 is on the circle with radius 13. We have given you the radius this time, okay? So slight variation, we are not giving you the center, we are not giving you the point, but we are giving you the radius and the point as A12 with this center. Oh, center at origin also is given to you. So we given you center and the radius. You need to find point on the circle where y coordinate is given to you. So that means very simple. Since y coordinate is given to you and radius is given to you, you can find the distance using Pythagorean theorem, correct? A square plus b square is c square. And that's what I did. O to p is the radius, which is 13, right? So with the square root of a square plus 12 square should be 13. And when you solve for a, you get the value of a as 5. It is a Pythagorean triple, if you remember, right? 5, 12, 13 are Pythagorean triples. So you get your answer.
Yeah.
Point is 5, 12. Once you know the point, then it's very easy to find the slope and negative reciprocal of the slope. You know the point. You can find the equation of the tangent. Clear? So that is how you'll do it. Another simple question, but these are good from examination point of view. The last question is the one where we are going to use not the distance formula this time, but the standard ways of solving such questions. Do you get my point now? So this is your standard way of solving questions. Till now, we never had a solution which will run through the whole page. But here is the one to end with. Okay?
Yeah.
No, it's a long solution. Can you please read what is it all about?
Yeah. Example 14. Write bisectors of chord intersect at the center of the circle.
Perfect.
Find the equation of the circle passing through the points A minus 1, 5, B 5, 7, and C 7, 1.
Correct.
So 3 points. Okay. Right bisectors of the chord will intersect at the center of the circle. Correct. Yeah.
Steps.
Yeah, so that makes sense. Yeah.
Yes.
Oh,
This is the
steps.
base, right? That is what you're talking about. When you have 3 points, make a chord, make another chord, find the right bisector of both. They will intersect at the circle. You have now a point. You have that point. Find the radius. Do all that. So we are doing all that. But these are the steps involved. And that is the standard way of answering a question based on all this, where we will not use the distance formula. If you don't use the distance formula, this is what you do, correct? This is what you do.
Okay.
And the steps are, can you tell me the steps now?
Yeah. So find the right bisectors of the chords AB and BC. Then find the point of intersection of the right bisectors, which would be the center O of the circle.
Correct.
And the radius would be the length OA, or any of the points. Yeah.
So first, right bisector of AB, then the right bisector of BC. To find the right bisector, find the midpoint. Very good. Find the slope. Correct. Perpendicular slope is negative reciprocal. We are calling this as a normal. Then the equation of the line, y equals to mx plus b. Find the value of b by placing the point on it. Then you get your right bisector equation. Follow the same process to get the right bisector of the second line. Things are not done yet. We have to find the point of intersection. We have to find the point of intersection. Okay, come on. Equate both these equations, left side and right side. Oh my God. And then find first x value, right? Because we eliminated y. Find the x value. Then substitute the x value, find the y value. And then you finally get the center, which is 3, 3 in this case. Substitute and find the value of the radius, which I didn't even write. Okay. Probably 2 square root 5. Okay. You know, you get tired doing all this. You don't know like where you are. So this is equals to 2 square root 5. So we got the radius, and ultimately when you have the radius, you know the equation is x minus h whole square plus y minus k whole square plus radius square. And therefore, you get your equation as x minus 3 whole square plus y minus 3 whole square equals to 20. You get it?
Wow. Yeah.
That's
long.
You won't believe it. That is how you are going to answer most of the questions in your textbook. You have to do all this all the time. Okay.
I just started doing some, and obviously I didn't do a whole question, but I have been noticing how I'm doing the right bisector like so many times. Even when they're wording it differently, I'm still doing the same thing. It's like repeating on and on and on. Whereas if I use all your different strategies, they're so much faster, easier, and it's a bit of variation, so it's nicer.
That's true.
Yeah.
And doing this
problem,
you get so tired. See, I'm not joking. I even forgot to write this value here, right? By that time, you're done, right?
By the time you get there, you're out. Yeah, that's true.
Okay. So that is how you will be doing it. Now, what I did was I added one more page. The idea of adding this page is kind of like this. We began with the circle equation. If I have a center HK, then this is my simple equation. Of course, I can expand this equation, and then I get 2hx and 2kx, as we shared with you earlier, correct? Now, in between, if I use 0, 0 as my center, then the equation is much simpler. X square plus y square equals to r square, right? However, we kind of didn't really like much, so we moved on to the same equation, which I wrote in not a very standard form. Normally, you will write this with 2, and you'll change with G and F, right? Oh no, that's a different equation. Let's leave it like this. Let's not complicate. So I didn't go to that complicated equation and equate all those things. But what I'm sharing with you here is, if we place the circle at different places, then see how the equation changes. Because in many equations, they will place with x-intercept, with y-intercept, x-axis as your tangent, y-axis as your tangent, both the coordinates axis as your tangent. Do you see that situation? So we have all those kinds of situations listed here, including the one which we took where the point is have x-intercept, y-intercept, and the origin. Do you see? Where you identified this as a diagonal. Do you understand?
Oh, yeah.
Different situations are there. Now, let's look into these situations and how the circle equation changes. So if the circle is through the origin, but we are using this complicated equation, the expanded form, in that case, R value is 0. Do you see that? If you compare with these two, correct? If you compare with these two equations, and if circle is through the origin, circle is through the origin, right? In that case, that constant, I should not say R, I should say that constant is 0. In your
like C.
That C is 0.
Oh, yeah.
Get the idea? So if you see an equation where that C is 0, I shouldn't say R, right? C is 0. In that case, you know the circle is going through origin.
Oh, I got it. Yeah.
You got the idea, right? So when circle touches x-axis, so if my circle is touching means tangent to x-axis, then I know that the y point is, we know the radius is same as the y value, right? So if I say a, so this value is -5, -5a. Is that, so center is at -5a. You're getting my point?
Yeah.
So what I'm trying to say here is that you should, when you do all these examples, let's get back to our examples. When you do all these examples, correct, at the end of it, you draw a chart saying, well, when the circle was touching x-axis, this is my equation. When the circle is touching y-axis, that is my equation. When the circle is touching both the axes, that is my equation. So make a chart, one full page, different conditions, and observe their equations. Once you see that, you will start correlating equation with circle. You get my point?
Oh, I get you, yeah.
Till now, you only know two ways. If it is at center, x square plus y square is r square. If it is not at center, x minus h plus y minus k square. But if I give you different forms, and if you correlate, you will recognize so many circles, like we did try to show you in this overview of circles. So make a chart like this. Is it okay? Relate with the equations. Let this be an exercise.
When it says circle touches x-axis and y, those two formulas are exactly the same. Is it?
Yeah, these formulas
How
are
do
not
I
quite,
show?
yeah, these formulas are not quite correct actually. I didn't really write them correctly. So ignore them for now, but get your equations and plug them in, right?
Okay.
I wanted
Can I send them to you because I don't really know?
Yeah, do it and then send it to me. I'll add here. Okay. So with that, we'll kind of wind up on this, but I'd like you to summarize what have you learned today.
Oh, great. Could you put that slide back on, the one that had all the things?
Sure.
It was so many.
Oh my God.
All I can summarize right now is that there are so many alternate strategies when dealing with circle questions. So obviously everyone knows the basic, like I said from the beginning, if it's at the origin, it's x squared plus y squared equals r squared. And if it's not at the origin, it's the x minus h whole squared, y minus k whole squared equals r squared.
Yeah.
So those are the two obviously normal ones. As you go later, like when we went through the lesson, we obviously came across more complicated questions, which so we've already come across the distance formula, which is very helpful in finding, let's just say, if you didn't, it's basically Pythagoras theorem, finding the radius or any distance right? Yeah, any
Yes.
distance between 2 points. The coordinate of a midpoint is very handy when doing right bisectors. So if you have a chord and you want to bisect it, finding the midpoint of the chord, so that's when you use that formula. Or if it's a diameter and you want to find the center, you can easily use the midpoint one. If you have the two, so the diameter coordinates, if you have the two endpoints, you can do it that way, or you can use this equation of the circle with the diagonal, which is very, very good. So I'm definitely writing that one down. It's so simple. All you do is simply plug in the values, x1 and x2, into the equation, and you get it perfectly in the form that they're looking for the circle.
Correct.
So yeah, and then we talked about intercepts of, equation of the circle.
Let me see. Distance formula 1. Yes, equation.
Oh yeah, so this one was new to me. Yeah, this one was new to me, but so this was quite handy when distance of a point. So let's say you have a point being x1, y1, and this equation, you only use it when you have a tangent and a center.
Correct.
And that's how you find the radius, because obviously that the radius is perpendicular to the tangent, so that's how you find out. So that equation is very good, and it saves so much time than doing like the whole process of what I was explaining in the beginning, to do like Pythagoras' theorem and like all of that thing. This one's so simple, just sub it in and you got your answer.
That is
and then what's the next one? Oh, 3 points. So we learned that 3 points, all you need is 3 points to define a circle, if it's obviously in the plane. And that's when we were talking about the two parallel lines, that one there. The two parallel lines one.
2 parallel lines, 2 tangents.
Oh yeah, 2 tangents. This one. 2 tangents like this, and the common mistake, even I nearly made it. So you can see the tangent obviously hits only 1 point on the circle, but that's not the point of the intersection with the line, y equals minus 2x. So don't mistake those 2 points where the tangent hits the circle as the diameter points, because that's incorrect. So you have to use the point of intersection lines, join those, and then find the midpoint of that, and then that would be the center of the circle.
Yeah.
So yeah, just looking out for the different positions of the circles. So I guess the task at the end of this lesson, which I'm going to do right now, is write all the different positions of the circles and match the different equations to the different positions, so that if I actually see it in the exam, I don't waste time trying to think of all the equations and be like, which one's the most appropriate, you know?
That is so true. So I think, Abby, you summarized it very beautifully, highlighting the main things in our video. What I realize is that circle is such a simple equation to work with. However, the way we treat it, we have made it very complicated. So right in the very beginning, I tried to show you the complications we put into it, and then how difficult the questions we can make. However, since we know that this is how complications has been created, we have found our ways to provide simpler solutions using distance formula especially, and understanding the position of the circle in the coordinate plane helps us to get clear idea about what the result should be. And we also see how we could relate a standard form of equation with radius and the center points. Easily we can read all these values. We don't have to always calculate and find it out. You can just write them straight away also. So in case we don't have to show these steps, there's a multiple choice test question. You can easily read those values and answer and move forward and save a lot of time. So I hope that is the key for today's lesson. From here, I expect you to do most of the questions from your book. And do it in different ways. Try to adopt the simpler method whenever possible. And those questions which you can't do from your book with your current knowledge, we haven't really completed. We have a part 2 of this lesson also. Share those questions with me so that I could now go to the next level, and we'll talk about examination review and examination style questions on this particular topic. Okay?
Great. Thank you so much, sir. I really appreciate it.
Thank you. And
now I feel confident to do the questions from my book. So thank you.
I'm also confident about it. Thank you.
Cool.
Bye.